Hi guys. So we will have a very interesting presentation. We are short on time. I'll start with presenting moving target defense, the concept itself, as stated by Homeland Security in 2016, but initially actually already in 2012 mentioned by NIST as a very important concept, basically to try and reduce the attack surface, reduce the windows of opportunity for the attackers to kind of probe and infiltrate and compromise the endpoints. Endpoints, networks, and other areas in the army industry, these concepts were implemented for a while. We'll talk a bit about the deception and the moving target defense and how it combines together. And we, in a way, automate it and commercialize it as a product to solve a problem, which we are going to present in the next slide. So definitely Homeland Security and the whole industry is going big leap step forward in adopting moving target defense. So let's go to the next slide. Let's define the problem. So the problem, as we see, and again, there are many reports supporting that problem, external reports, third-party reports. Some of them are described as a PICA security reports. Some of them delivered by Red Canary and other universities. They all kind of take the existing threat landscape and try to map it to the different techniques or tactics that are utilized by malwares. This is important for us to understand where the malware landscape goes to and whether our current security stack has a gap to cover those threats. And we identify very quickly, based on the different reports, that many of the first techniques and tactics are focused around defense evasion, evading the current security landscape, the current EDRs, XDRs, EPPs, and AVs, by means of basically being stealthy within the memory, within the legitimate applications, as it's very hard to detect this kind of threat. And we also see a very sharp increase in credential dumping, credential access techniques that are implemented by the different malwares for later re-engage, lateral remove, or re-access the environments. And again, those kind of things also target specific applications that process and maintain those credentials. So essentially, the question is, does the current security stack able to handle this landscape of credential access, in-memory defense evasion? And what we basically will prove following in the next couple of slides later on in the presentation, that it's a really challenging problem for a detection solution because they essentially apply scanning, known behavior matching, known dynamic analysis, but known as the kind of the key point. They have to be based on already intercepted signature attack and behaviors. And there is impossible to scan the application endless times while it constantly changes its status. So we'll introduce moving target defense to solve this problem, and we'll describe it in the next couple of slides. So let's move to the next slide. So let's for a second kind of quote the Gartner reports, which are doing amazing work. Gartner are covering moving target defense. They actually call it AMTD, automated moving target defense, which sounds much more reasonable, and we'll explain why it is so. But where does it come from? So, and essentially, if we look at that automated moving target defense, based on many of the different companies that are right now implementing that, and we'll get to that, including Morphisec, is composed of moving target defense, and a deception concept. So what is essentially a deception concept? Many of you probably are aware. Again, there are some companies in this field that's basically kind of putting decoys, booby traps, honeypots in a way to lure the attackers to those decoy elements. This is a great non-traditional approach, which is important because you are limited to what you can solve with traditional approach. Homeland Security says that perfect security is unattainable. So how do you complement this gap with a different approach? So deception is an approach, is a preventive approach. Unfortunately, it doesn't protect the existing resources and assets that you have. It definitely prevents an attack in some cases, but if the attacker gets to the real resources, then your risk still there. Moving target defense is doing a bit different. It's basically shifting and changing your resources, and the resources could be IPs, could be networks, could be application memory structures, could be credentials, could be everything. So the moving target defense is basically shifting them and hiding those assets, but it lacks the visibility following the prevention of the attack, because essentially in many of the implementations of moving target defense for the different companies, we'll find hey, containers are shifted, networks are shifted, but you don't really know that you are being attacked, which is important for visibility purposes. So Morphisec automated moving target defense and what we basically implement is a combination of the two. We need the prevention, the visibility, but also reducing the attack surface. And we need to augment the existing gap that currently exists with NGAV, PP, EDRs, XDRs, etc. Now, prevention is kind of a key word here that differentiates us immediately from all the rest of the world, which kind of focuses on detection and response and trying to minimize this gap of time. Prevention is very important, especially when the attackers are compromising environments within a minute, within hours, within days, within some weeks. Okay, let's continue to the next slide. For the sake of education, we are talking about moving target defense. We are not the only one. We have great colleagues that are trying to cover the different security stacks as defined by Gartner. Target defense can be implemented on APIs, shift left, on networks, on Kubernetes, on containers, even on the hardware. Some of you may be familiar with the Morpheus chip. All its focus is trying to solve the in-memory exploit issue by basically shifting pointers utilizing hardware capabilities. Hopper is rotating credentials in the containers. R6 security rotates network topology. We have Dispel shifting virtual machine networks, code randomization, and essentially Morphisec MTD as the leader in moving target defense application assets and resources. And we support both Windows and Linux. So let's continue to the next slide. So we need to talk a bit about what Morphisec does and how do we implement moving target defense, automated moving target defenses. So again, what do we protect here? We protect, as I mentioned already, the application runtime memory, application credentials, application assets and resources. But additionally, we also implemented additional protection on the ransomware, anti-ransomware solutions. In a way, we introduce moving target defense to the file system. We protect recovery, tempering of recovery technologies, and basically introduce a very good anti-ransomware solution. So what do? We are extending the Windows and Linux loader. And basically every time the application loads, we create kind of a trusted zone within the application memory. We change how function looks like. We change how structure looks like, only how they looks like in the memory without changing the integrity of the application flow. So basically, if the application works function X, it will work with function Y, etc. So basically, a lot of different changes. We are supported by at least 7 patents, which are already confirmed, and some are on the way, different stages. And when we create this trusted zone and untrusted zone, basically any new foreign introduced code is not familiar with this random trusted zone. Now, it's important that this trusted zone, this randomized morphing changes are unique per application that is being executed, per endpoints, per application, per initialization time. So if the application respawn again, everything is different. So it protects from laterally moving even from application, even if you identified what are the different compromised resources. Now, the important concept Homeland Security actually mentions, our goal is to make it more expensive for the attacker. Not everything can be solved, but if it becomes more expensive, the attacker spends a lot of time on creating this attack, trying to bypass this trusting zone. We essentially achieved our goal, and the attacker will opportunistically target different weaker areas. Let's continue with the next slide. So basically, when we have a foreign code introduced, tries to identify the landscape, tries to identify what are the different changed resources. We not only move the function names, we don't only change the links, we not only move the different resources. As we mentioned, we also introduce deception. We introduce kind of a booby traps within the memory. And due to that, basically this foreign code being intercepted and it would fail either way. But we also know very interesting threat intelligence that we can provide and share with the community that can help definitely with the additional preventive measures and your other solutions. Let's jump forward. Okay, so we described kind of very quickly moving target defense concept that we implement on the application memory. or applications runtime, whether you control the application or whether this is a third-party application, off-the-shelf application, anything that runs within the environment. It means any process. We need to understand what is the current security gap. We mentioned the efficacy gap in a way by presenting the reports by Red Canary, by PICOS reports and other reports, which are telling us 30%, 40% of the attacks are in memory. Additional percents, 20% are like credential tapped from the application memory. But there are additional gaps that exist today. When you are working with your security stack, such as EDRs and XDRs, you have issues with supporting legacy operating systems. You have other operational issues of alert fatigue, right? Trying to handle and process all those alerts that are coming and processed from the other solutions. And in many cases, you may disregard those alerts and you may not have resilient security that can protect your operating system, legacy operating system, or critical system, or even sensitive systems. And this is a very important gap that we want to cover additionally to the efficacy. So let's move to the next slide. So again, very quickly, because we are on the end of time that we have. So again, we provide automatic legacy operating system protection, protect sensitive environments quite easily. We have a preventive approach, and we are focusing on those attacks that really bypass the security solution, and therefore moving target defense really can cover this additional gap that is important still to cover with the other threat still need to be covered by your existing solutions, which are great for visibility and non-threat protection. Let's continue with the next slide. This is some of the examples of different customers. Most of the cases, 99% of the cases, we are installed side by side with existing EDRs or XDR solutions. We have here cases of SentinelOne, CrowdStrike, and others. They operate a bit differently. You will find that we, as a last layer of defense, find some attacks that penetrate some solutions in memory. Other solutions are more relevant to custom packed executables. In many of these cases, if not all of the cases, we still find Cobalt strikes, backdoors, Metasploit backdoors, Cuckbot Trojans, ransomwares, which are side-loaded DLLs. We can dive into many of those use cases, but the fact is still that after bypassing the first scanning, they get to the Morphisec prevention layer, and we prevent them, and we'll show an example of that case in the next demo. We can jump very quickly over the slide, but the slides essentially says, hey, we have tons of threats here, and even if EDRs and XDRs catch, and they are intercept many of those threats at a specific time, the question is this gap of the threat happening, and then different AVs, EDRs, updating their behavior signatures, the dynamic signatures, what happens in between. And there are always someone that is being attacked. First, second, third. In some of the cases, we find out the leading EDRs have 3 weeks until they update their signatures, or 4 weeks, even behaviors.